Okay, in this section, we are studying first order differential equations again. And we got a different way that we can solve them. Other than, we've done integrating, we've solved differential equations by separating variables. Now we're going to use something called standard form to help us identify parts of a first order differential equation. So here's standard form, okay, where you have the first derivative, because it's a first order differential equation all by itself. And you have some p of x, which could be, I think it would be x to the third, could be 2, right? Some sort of function times y. Notice that's not the derivative. And then that should equal some function q of x. So if you can rearrange a differential equation to this form, then we can use this technique that I'm about to show you, an integrating factor, to help you solve. Okay, so an integrating factor we define in calculus for this particular situation. We call it usually m of x, and that's what your book uses. It's e to the power of the integral of p of x, this part, with respect to x. Okay, so that's just a particular function that we find based on our first order differential equation in standard form. And once we have that, the book has one explanation, but I think it's easy. It might be easier. I should say might, because it's easier for me. I want to offer this formula. This is a straightforward formula to plug everything in, do some calculus, and then you can get y, the function that we're looking for that's a solution. It's 1 over your integrating factor, m of x, times the integral of m of x times q of x dx. Okay, so if you can find mx, plug it into this formula, plug q of x into this formula, and then evaluate the indefinite integral, then you've got a solution to the first order differential equation. So let's see, I think I got an example here. Yeah, so here's an example. So here's a first order differential equation already in standard form for us. Okay, so the first thing to do is to find m of x, the integrating factor, and that's e to the power of the indefinite integral of 3 over x dx. So careful with that antiderivative there. When you evaluate and then simplify, you're going to get x to the third. Okay, that's our integrating factor. So to find out y, the solution to the differential equation, it's 1 over our integrating factor times the integral of our integrating factor times q of x, which is this part over here, right? 4x minus 3 dx. And then the rest of this is calculus that we've done before, right? So do a little bit of algebra. That's 4x to the fourth, subtract 3x squared with respect to x. So when we integrate that, that's 4 over 5 x to the fifth subtracted by, that should be 3x to the third, sorry. 3 over 4 x to the fourth plus c. And then when you distribute that 1 over x to the third, you get 4/5 x to the second, subtracted by 3/4 x plus c over x to the third. And then you can solve for c if it's an initial value problem, right? You can plug in a number for y, plug in a number for x, and then solve for c. Okay, so I do recommend trying that. That helped me out when I first was learning about this particular way of solving first order differential equations. Yeah, that method, the book takes things in a slightly different direction. I think they ask you to multiply both sides by the m of x, by the integrating factor, which you can do. Will get you the right answer.